Hi there. My name is Vincent. I'm an engineer over at Probable, and in this video I would like to highlight some new features in Scikit-LEARN version 1.5. It is a pretty big release with lots of features, and although I won't be able to go through all of them, it is my goal to highlight a few things that I think might be worthwhile to emphasize. Now, before showing these features and diving into the code a bit, I do want to acknowledge that Scikit-LEARN is a big community effort, and this release is no exception. If you scroll down to the release document, you are going to see a long list of names of people who have contributed and helped improve the project. I would like to thank everyone involved because it has been a big community effort, but also because I'm just presenting other people's work. Once again, thanks to everyone involved, and let's now dive into some of the new features. So let's talk about some new features. I am inside of a Jupyter notebook over here, and what I would like to do is talk a little bit about thresholds. To explain this topic, I have set up a somewhat artificial situation. I am generating some classification data using the make classification functionality inside of the datasets module. I am then creating my train and test sets using the familiar train test split. And then I have a classifier down below, which is a logistic regression with random state set to 0 for reproducibility. I then train the classifier as you would normally. So that means that this classifier variable over here contains a trained logistic regression. Now this classifier can also make some predictions. So one thing I could do is give it my test data, and it would go ahead and make some predictions on my behalf. Note that in this case I'm dealing with binary data, so I should be getting a bunch of ones and zeros out. But if I really wanted to, I could also ask for these probabilistic predictions instead. These predictions are a little bit different because we are now getting values that feel like probabilities. We get values between 0 and 1, and the larger a value is, the more likely a specific class could be. And inside of scikit-learn, it's these probability values that eventually will get translated into a 0 or 1 prediction. Because we're dealing with a binary classification here, the way that this typically works is we have some sort of a threshold. If on one end of the spectrum we've got 0 as a probability value, and on the other side we've got 1, then we got to make the cut somewhere, and typically that would be at the 0.5 mark. Everything on the left-hand side would be class A, and everything on the right-hand side might be class B. But you could wonder, well, maybe that threshold deserves to move around a bit. Depending on your classification task, you might be more interested in one label over the other. That could be a reason. But you might also be more interested in the precision for a specific label. That's also something you might be interested in. I wrote some code to highlight this, so let's look at that first. And here is the aforementioned code, where I'm looping over a range of values, and to be specific, I'm going over 200 steps here, and then at each step, I am going to say, well, the actual predictions that are going out of my model, those are going to contain the proba values, but the threshold is something that I get out of the for loop. And then I can start measuring things. I can say, well, let's keep track of the threshold, but I'm also keeping track of the F1 score, the precision score, the recall, and the accuracy. As this for loop runs, I'm accumulating and accumulating, and that allows me to make a chart that looks like this. You can see here that as we have different values for our threshold, that we then also see different statistics for our metrics over here. This green line over here is the accuracy. And we can see that for accuracy, as long as we're above a threshold that's about here, let's say that this line over here is relatively flat. But this is not the case for the other variables. We actually see that they vary quite a bit. When you look at this chart, you might start to recognize that we can actually gain a lot from tuning this threshold ourselves. We can do this for logistic regression, but we can also do this for other classifiers. But there are just lots of these properties that do tend to be somewhat sensitive to the threshold that we've got over here. And one thing we could do is we could make these charts ourselves manually, and then manually also figure out what threshold we like most. And there's definitely something to be said to maybe do that. It's not a bad practice. But there's also some value in automating this, and that is something that scikit-learn 1.5 can now do for you. Enter our new component, the tuned threshold classifier. From a distance, it might look a little bit like a grid search. We are definitely doing cross-validation. That's what the CV stands for over here. And just like a grid search, you can pass it a estimator. However, a few differences. We do expect that you're passing a binary classifier when you're passing in an estimator over here. And also, all the tuning that is going to happen here will not happen on hyperparameters. We are really just looking for a response method, which is typically the proba value, and we're really just tuning the threshold. You can still pass your own score if you like. In this case, I am sending a score for the F1 score, but nothing is stopping you from putting anything custom in here. You can set the number of thresholds, and what you can also do is run the search in parallel. This is definitely a nice feature because my for loop doesn't do that. I'm going to call this classifier other threshold because we are looking for a classifier with another threshold, and we again can run the familiar fit command to fit it. The HTML widget that follows actually shows us that indeed we are basically running logistic regression inside of this estimator over here. And because I've opted to also store the cross-validation results over here, I am also able to inspect them in hindsight. So that means that the chart that you're looking at over here is the hill for the F1 score. So that means that given different thresholds, we can see that there are different values for the F1 score. We can also see that the peak is somewhere over here. And it's good to note that it's the F1 score again, because that's what I'm passing in here in the scoring. But another thing that's also good to observe is that the shape that we saw just now, that blue shape, is the same that we also saw with our manual code over here. So the results are exactly the same, which is what I would expect, but it is definitely very nice that we now have a proper cross-validation estimator for this use case. Tuning thresholds can definitely be worth your while. So if you're dealing with a binary use case, definitely check out this new feature and give it a spin. It really can help you just get that little extra oomph out of your model. If you are interested to learn more, then you may appreciate this guide on the new documentation page. It goes over a bunch of details, but in particular it showcases a nice use case for adjusting the threshold when you are dealing with a business outcome. In particular, you can imagine that a false positive might be worse for particular use cases compared to a false negative, and this thresholding technique also allows for custom scoring metrics. So if that sounds interesting, check out the show notes because I will be adding a link. The next feature that I wanted to highlight is somewhat smaller in the grand scheme of things, but I do think it's a nice addition. Just like before, I have a very familiar setup here when it comes to classification. I'm generating some data, I'm splitting it for my trained test sets, and then I've got a classifier, which is again a logistic regression down below here. However, the next thing that I do is I put that inside of a grid search object, which is the main object for hyperparameter search inside of scikit-learn. I am going to be looping over this one hyperparameter, which is a regularization parameter for the logistic regression. And when I declare it, you can see that the HTML looks a little bit like this. I can see that I'm dealing with a grid search estimator, and you can also see the estimator in depth. Next, what I can do is I can train it, and here's where something interesting is going to happen. First of all, you can see that the color is now blue, where before it was orange, and this is scikit-learn way to indicate that we're dealing with a trained pipeline over here. That's not necessarily a new feature, but the next step actually is. I can now inspect this logistic regression, and I can see the hyperparameter that the grid search has found to be best. So that means that if you're interested in understanding some of the details of the parameters that have been found, you can actually get that from this visual element going forward. And this is nice if you're dealing with just a simple component, but if you're dealing with a more elaborate pipeline here, you can definitely see the benefit of this. I can also hide it if I just want to keep the pipeline small though. The next two features are somewhat hard to demonstrate inside of a notebook, but I do want to call them out explicitly by just pointing at them in the docs. As of version 1.5, we have a lot more components that can do metadata routing. This is a large effort, and it's definitely cool to see that we now have more components that support this. Definitely check out this list if you're interested. Another nice small little detail concerns the datasets API. There are lots of datasets that you can fetch from the internet. These include the 20 news groups dataset, as well as maybe California housing and lots of others. Because these datasets are downloaded from the internet, you might suffer from a hiccup that prevents this from being downloaded. And to help out there, we have now added optional arguments for the number of retries as well as the delay between the retries. which will hopefully catch a lot of these network hiccups. By default, the function will try again 3 times in case of a network failure. Scikit-LEARN is a great tool for text classification, which is why I was very keen to see this feature being added as well. The TF-IDF transformer, which is a great featureizer when you're dealing with text data, is now faster and more memory efficient. Text datasets can get huge, so this is definitely also a nice feature. The final feature that I wanted to mention explicitly is that the predict call inside of the histogram gradient boosting classifier is now just a little bit faster. We're now avoiding a call to predict proba that's not always needed, and this caused a speed up. Given the fact that this is one of the most powerful ensemble models out there, I figured this would be nice to mention because you might actually notice a little bit of a speed up if you're calling predict on large chunks of data. It's not the only PR that's made a speed increase. There is also this other one that's not just making the classifier a bit quicker, but also the regressor. But the main thing I wanted to emphasize is that it's just kind of nice that we see these efficiency improvements as well. It's not always about new algorithms, sometimes it's also about improving existing ones. Finally, there's also one extra change that you may not notice as you're using scikit-learn directly, but what you may notice if you go to the documentation page. Going forward, there is now a new PyData theme that scikit-learn will be using, and this comes with a couple of benefits. For starters, there's now an option to go for a light or a dark mode. Another nice benefit is that you can also easily switch the version number for different versions of the documentation. But some of the code examples now also have a nice extra feature when you look at these code snippets. If I were to just zoom in on this particular example over here, you'll notice that there's a couple of functions that have a line under them. Now the cool thing here is that you can actually click some of these functions to get the documentation page for that one function in the example. That means that if you ever see a code example where there might be a function that you're not familiar with, then it should be a lot easier to immediately dive in. Now remember, this is just a style change with extra features, so you shouldn't be afraid that any content is gone missing. If you click the API section over here, you can still find all the different methods and submodules of scikit-learn, and all the information can definitely still be found here. The site only looks a little bit different and has some extra features, and the hope is that this in the long term will also make it easier to navigate to new sections of the site. This was a summary of all the new features in scikit-learn 1.5. There are definitely features that I've not talked about, so if you're interested, have a look at this document. I will make sure it's in the show notes. And having said all this, once again, thanks to all the contributors, and I hope that you enjoyed watching this video.